Okay, so in this video we're looking at logs, and logs is another word for powers or indices. Okay, so first of all I'm going to bring you to page 21 of your log tables, okay, and here we have a number of laws of logs that we need to be familiar with, and you can see they're written right beside the laws of indices because the two of them are totally linked, of course, because indices is another word for logs and vice versa. The first thing, though, before we can get into the laws, is that we need to be able to go from power form to log form. Okay, so this is your little bit of information here in the log tables that helps remind you how to do that. So we're going to do a number of examples doing this first, so we can get totally familiar between going between the two forms, and then we can have a look at each of the laws. So let's write this down. So this says that if you have a to the power of x is equal to y, then another way of writing that in log form is log of y in the base a is equal to x. Okay, now we'll take a look at this with some numbers. It'll make a lot more sense. But just to show you, first of all, your power is probably the easiest thing to fill in. The log is always equal to the power because that's another word for it, of course. So that's the first thing that's probably the easiest to identify. The log has always got to be equal to the power. Then the base, whatever is the base in the log, is whatever is being raised in the power. Okay, so in this case it's a to the power of x. A is what's being raised, therefore A is the base. And then of course that leaves us with the y, which is here. And that is of course here. So the reason it's so useful to put it into log form is because putting into log form allows us to be able to solve for powers in a really quick, efficient way, okay? Up to junior cert, the only way that we had for solving for powers was to be able to write the left-hand side like the right-hand side, and once we kind of got them looking very similar, we were able to pull out what powers were equal, okay? So this log is going to allow us to actually very quickly, as I said, find those powers, and we can use the calculator a lot as well to help us once we use the log form. So first of all, let's just get used to going from power form to log form as I suggested. So we'll do one example together first. Say you have 2 cubed is equal to 8. Well, to write that in log form, well, as I said, the easiest thing to fill in first, of course, is the fact that log is always equal to the power. So the power here is, of course, 3. Then the next thing that's easiest to fill in is the base. The base is always what's being raised, so that is the base 2, and therefore we're left with 8. So log 8 in the base 2 is equal to 3. Okay, try this one. 3 to the power of 5 is equal to 243. Pause the video and write this one in log form. Okay, so we have log. Remember, the easiest thing to fill in first, of course, is what the log is equal to. In other words, the power. So the power is, of course, 5. What's being raised is 3. Therefore, 3 is the base. And, of course, I have 243. Try this one. 6 squared is equal to 36. Pause the video. Write this one in log form. Okay, so again we have log is always equal to the power. The power is of course 2. What's being raised is therefore the base. And of course 36 then goes in here. Let's try another one. 4 cubed is equal to 64. All right, write that in log form. Pause the video, see how you get on. And of course we have log is equal to the power. The power is 3. What's being raised is 4, therefore that's the base. And so we have log of 64 in the base 4 is 3. Let me just show you something at this point. So for example, if I was to use the calculator, here's the button that's going to help me. Do you see where it has log? So if I press log, and I have the 2 boxes I can fill in. So I'm going to fill in, let's say, the base 4 and then 64. And of course that should be equal to 3. And it is, of course. So there we go. That's how we can use that button on our calculator. Let's try one last one. 7 cubed is equal to 343. Pause the video and write that in log form. So we have log is equal to the power is, of course, 3. what's being raised is 7, and we have 343. Okay, so this time we're going to go the other way around. I'm going to give it to you in log form, and I want you to write it in power form. Okay, so we have log 81 in the base 3 is equal to 4. Pause the video and see if you can write this now in power form. So the easiest thing to start off with here, I suppose, is the base, because the base is what's being raised. The power, of course, is 4, and therefore it is equal to 81. Let's try another one. Let's try log of 32 in the base 2 is equal to 5. Pause the video and write this one in power form. So again, start with the base. 2 is being raised. 5 is obviously the power, because log is always equal to the power, and therefore 2 to the power 5 is, of course, 32. Try this one. Try log of 729 in the base 3 is equal to 9. Pause the video. Okay, so again, the base is 3. 3 to the power of 9 is equal to 729. All right, last one. Log of 100 in the base 10 is equal to 2. Pause the video. So that would be 10, which is the base, to the power of 2, which is obviously what the log is equal to, which is equal to 100. Okay, so now we're going to take a look at the laws of logs. Okay, so let's have a look at the first one as it is written in our log tables. So this one here is totally linked to the first law of indices that we have over here on the left hand side, because of course logs are equal to powers. So you can see that you can add the powers when you have two things that are multiplied. So do you see the way the x is by the y here like this? Xy, of course, is the same as x times y. So when you have two things multiplied, you can add the powers, and that's what we have over here, remember. A to the power of p times a to the power of q. If you have them being multiplied, you can add the powers. So here's the first law. Okay, so what this law allows us to do is it allows us to simplify up logs, or sometimes we might want to expand. We might want to go from the left hand side to the right hand side. Mostly though, maybe you're given something in this form and we want to simplify it up to this form. Okay, right, well, let's jump straight into an example. Let's say, for example, we were asked to simplify log of 6 in the base 2 plus the log of 5 in the base 2. Okay, so analysing what I have here, you see when you have two things that are added, your two powers are added, then what you can do with those two values here is you can multiply them together. Now the key thing is, of course, is that your bases have to be the same. So do you see the way we are in the very same bases here? Okay, now that's very important. It's very similar to the fact that when we were dealing with the laws of indices, again, you couldn't simplify unless it was the same thing being raised. Okay, like here it's a to the power of p times a to the power of q, and that's why we can get a to the p plus q. Okay, it's very important that you have the same number being raised. Like here, it only works. You can only simplify and apply this law if you have the same basis. Okay, so these are the same. In this case, these are the same. So what I can do is that is equivalent to the log of 6 times 5 in the base 2, which of course is equal to log 30 in the base 2. Okay, so let's have a look at the second law now. And the second law in the log tables is where you have division, you can subtract the powers. Okay, you're subtracting the two logs, and logs is another word for power, remember? So again, if you look over here to the left, it's very much linked to our second law of indices that we have, where when you're dividing, you can just subtract the powers. Okay, so this is where it comes from. This is what we have, and of course this value here matches this value here, and if we're dividing by this, then that's what we can subtract. And again, you have to make sure, of course, your bases are the same, otherwise you cannot do this. So we'll take a look again at a numerical example. So let's say you're asked to simplify log 10 in the base 3 minus log 5 in the base 3. Okay, and again, this will simplify too. Pause the video if you want to try and write this down ahead of me to see if you've got a good handle on it already. It is, of course, log of 10 divided by 5 in the base 3, which is equivalent to log 2 in the base 3. Okay? Now, you won't always have numerical logs to simplify because obviously you could evaluate these on the calculator if you're allowed to just give the answer. You may have to give it in log form, in which case the calculator won't help you with that because the calculator will just evaluate it to a value. But often what happens, you see, is you're given it and you're given some algebraic terms in there. So you're given it, you know, maybe A's and B's and X's and Y's. But it's just easier to just get a handle on exactly what the law is actually saying and how to implement it. It's just easier to take some examples in numerical form first. We will have a look later on at some when they get a little bit trickier, as I said, dealing with letters instead of numbers. So before we move on to the third law, let's just try an example here where we're dealing with the first two laws together, okay? So this is a type of question. I'm giving you numbers, but I don't want you to use a calculator or evaluate it because you have to give me the answer in log form. So you're going to have to rely on your laws of logs in order to simplify this up. Right, pause the video, see if you can give this one a go. Okay, so the first thing I'm going to look at is my addition here. And of course, for my first law, I know that what I can do with this is I can multiply those numbers. If the logs are being added, I can multiply the 7 times the 6. Okay, and then that would give me, of course, 7 times 6 is 42 in the base 4 minus log 3 in the base 4. And now our second law, all right, with the subtraction, what I can do with that is I can divide the numbers. So I have log of 42 divided by 3 in the base 4. And 42 divided by 3 is 14 in the base 4. So this whole expression simplifies to, in log form, log 14 in the base 4. Okay, so let's take a look at our third law. Now, here's our third law, and this one is totally linked to this one over here, where we have a power to a power and we can multiply the powers. So that's what I have here, if you like, because log is a power, so we have another power up here as well. And what you can do is bring that down in front and multiply it to the log. In other words, you can multiply that power q that's up there to the log, which of course is the power. So you see the way it links into this one? A power to a power, you can multiply the powers. So it's the same thing here. If you have a power within the log, which is a power already, you can bring it down and just multiply it. So here's what we have. Let's jump straight into an example. Okay, so another way of writing log of 6 squared in the base 5 is to bring that power down in front and multiply it to log 6 in the base 5. Okay, so we do have this multiplication in here, you see. Now you don't need to write the multiplication sign, obviously, because 2 written beside the log would imply that times. So 2 log 6 in the base 5 is another way of writing log 6 squared in the base 5. Okay, let's jump into an example here of how this would be useful to us. Let's say you have 3 log 2 in the base 3 plus log 4 in the base 3 minus 2 log 1 in the base 3. Okay, and we need to write our answer in the form log b in the base a equals c. All right, so we need to rely on our laws of logs. We can't just put this all into the calculator. Right, pause the video if you want to give this one a go. Otherwise, listen on and I'll go through it thoroughly. Okay, so what I have here, the issue is I can't start getting into simplifying this addition because I have this 3 in front. Okay, so that's a problem. We can't apply that first law of log when you have something in front of the log. And just like I have here, that 2 in front of the log there is going to stop me from being able to apply anything to do with the subtraction of laws, which is our second, the subtraction of logs, should I say, which is our second law. So the first thing I'm going to do is use my third law to rewrite this, okay? So if I have something in front, I can rewrite it as log 2 in the base 3 cubed, bringing that 3 from in front to the power, okay? So plus log 4 in the base 3, I'm going to do the same thing over here and bringing that 2, which is being multiplied, back up to the power, okay? So what that gives me is 2 cubed, of course, in this case I can evaluate it, which is 8 in the base 3, plus log 4 in the base 3, minus log 1 squared, of course, is 1 in the base 3. And now applying my first law, if I have two logs that are being added and they're both in the same base, I can, of course, just multiply the numbers. Take away then the log 1 in the base 3. Well, on the left hand side, 8 times 4 of course is 32 in the base 3. And now if I want to tidy up the subtraction, I'm going to apply my second law, which says that if you're subtracting logs and they're the same base, I can of course divide those numbers. And log 32 divided by 1 in the base 3 is 32 in the base 3. Okay, so this brings us on to our fourth law, which says this: log of 1 in the base A is equal to 0. All right, so looking in our log tables, that's where it is. This is linked to this law of indices, which, if you remember, says that anything to the power of 0 is 1. So that means when you have log of 1 in any base, the power is always 0. Okay, the minute you see log of 1, regardless of what the base is, it's always going to result in 0 because it ties in with any number to the power of 0 is equal to 1. Okay, our fifth law is this one. So this one suggests that log of 1 over x in the base A is equal to minus log of x in the base A. Now again, if we remember what this is linked to, this one is linked to, of course, this law of indices, where if you remember, a to the power of minus p is equal to 1 over a to the power of p. So if you remember from this one, we did a lot of work on this in our videos on indices. And it is worth looking up those videos on indices if you haven't done so already before you jump into the logs, because as I said, they're so linked. It's really useful to work through those two videos that I have on indices to be totally familiar with them, and that would really help your understanding of the logs. But a to the power of minus p, if we remember, the minute you have a minus power, that immediately is the 1 over. And then what's left? Well, a to the p is left, so a to the p goes underneath. Okay, the minus is literally the 1 over, and then a to the p is here, a to the p. So similar here, right? The minute you have the 1 over, you've got the minus. And of course, you have log x in the base a left, and of course, that's here, log x in the base a. The 1 over is the minus, and then whatever's left is here. So that's what that law is saying. So let's take a look at this example, and this has a mix of both laws 4 and 5. So pause the video if you want to give this one a go. So the first thing I'm going to deal with is the fact that I have this 1 over 3. So what I can do with that is I can write that as minus log 3 in the base 2. Remember, the 1 over literally is the minus, and then you have what do you have left? You have log in the base 2 of 3. Okay, so in other words, log 3 in the base 2 is left. Do you see the way that works? So I have log 6 in the base 2 here. Now subtract log 3 in the base 2, and I also take away log 1 in the base 2. And again, all our bases are the same. Now the minute you have log of 1, no matter what the base, immediately, of course, using our fourth law, I can write that as 0. Okay, so fill this in again. Everything else, all I've done here is change this one to 0, because I know the minute I have log of 1, no matter what the base, the answer is 0. So now that leaves me with just this to tidy up, and of course we're subtracting our laws. our logs. So this is the second law, remember. So that is log 6 divided by 3 in the base 2, which of course is log 2 in the base 2. Okay, so the last thing we need to look at is the change of base law. And this in your log tables is over here. All right. Now, this is particularly useful when you are given the logs and they have different bases. Because remember, the only way to apply any of these laws of logs is if everything is in the same base. That's the only way that these work. So if you're given logs and they don't have the same base, you can use this law to change the base of one of them to match the other, okay? Now, this looks quite complicated, so we're going to go through this in a lot more detail to make sure it is clear. So let's say you have a base B, but you want to change into a new base A. Then what you do is, so whatever you have here, in this case your x, you will take that x and put it into the new base that you want, and then you will divide the old base, log of the old base, again in the new base. Okay, so A is your new base. So it's going to be log of x in the new base divide by log of the old base in the new base. Right, let's jump straight into a numerical example so we can see this at play. Okay, so let's say we have log 5 in the base 2 and we want to change the base to a base 3. Okay, that's what we want. We want to put it at base 3 because maybe there's other things in the expression I'm given that have bases of 3. Okay, so what I'm going to do, that will be equivalent to log of 5 in the new base, okay, divided by log of the old base in the new base. So you see here what we have is log of 5, put it into the new base, then just divide by log of the old base in the new base. Right, again, let's take another example. Let's say you have log of 16 in the base 2, and I want to change the base to base 4. Okay, pause the video and give this one a go. So this will be log of 16 into the new base, divide by log of the old base in the new base. Let's try another example. Log of b in the base 9. Okay, let's say we have log of b in the base 9 and we want to change the base to a base 3. Pause the video, see how far you get with this one. So this would be log of b in the new base, divide by log of 9, the old base, in the new base. Now, if you have something like this, which is often what might come up, where you have a b, for example, instead of a number, but when you do the log of the old base in the new base, we have just numbers on the bottom. Well, we can evaluate that further for ourselves, of course. And obviously log b in the base 3, there's nothing more we can do that because we're dealing with a b and not a number. But as I said, we could, if we needed to evaluate log 9 in the base 3 further. So again, let's use our calculator. And using that button we have here, we are going to put the base 3, so log 9 in the base 3, and of course that works out to be 2, because the power is 2, when 3 is being raised, 3 to the power of 2 is of course 9, so that's where that's coming from. But again, you can use the calculator if you're unsure. So log 9 in the base 3 evaluates to 2. So just to show you a few little things that might come in useful, another way of writing this is log b in the base 3 divided by 2 is the same as a half of log b in the base 3. Okay, so that's equal to that. And another way of writing this, of course, using our law, our third law, is we could rewrite, if we wanted to, it might be useful to do it, it might not, but we could rewrite that half up as a power. Okay, so that's another way of writing that. Again, it may be useful to you to do so. And one final way that we could write that answer is we know from our laws of indices, of course, that b to the power of a half is, of course, the same as square root b. Okay, so again, that's just another way we could write that same thing. Okay, so this is our final example. So if you're feeling confident, press pause now and give this a go. I'm going to give a little hint if you want to just wait for the hint first and then press pause to see how you get on. Straight away, what you need to be spotting is that we don't have the same bases. Okay, so to simplify this up, we've got a problem straight away. So obviously this one's the base 2 and this one's in the base 2. So the first thing you're going to want to look at is changing this to the base 2. Okay? Okay, pause the video here if you feel you want to give this one a go. So as I said, what I'm going to do is I'm going to change this one. All right, if I have the other two in the bases of 2, then if I had this one in the base 2, I would be able to apply my laws of logs and simplify this up quite nicely. So what I want to do is I want to change log b in the base 4 to a base of 2. Okay, so in order to do that, from your change of base law, it's going to be log b in the new base, base 2, divided by log of the old base in the new base. Okay, so we have this. So now, because this is all numbers on the bottom, nothing more I can do, of course, with log b in the base 2, but because I have log 4 in the base 2 on the bottom, I can evaluate that. So log 4 in the base 2, log 4 in the base 2 is equal to 2. And of course, because 2 to the power of 2 is equal to 4. So the answer, of course, is 2. So now, another way of writing that, of course, is a half log b in the base 2. So that's the way I'm going to put this back in here now. Okay, so what do I have? I have log a in the base 2. Now instead of this, I have a half log b in the base 2 minus 2 log a in the base 2. Now we've seen before where I can't apply my laws of logs while there's something in front like this, okay? So what I'm going to do is I'm going to apply my third law of log to bring this from down here being multiplied to up here as a power. So that's going to give me log a in the base 2 plus log b in the base 2, and b to the power of a half, I can bring that from here up to the power using our third law. This I can bring up here. So 2 log a in the base 2 is the same as log a squared in the base 2. And now, when I add my logs, of course, I can multiply. So a times b to the power of a half, which is ab to the power of a half, if you want to write it like that. There's a few different ways you can write it, of course, and I'll show you them all. And then I'll have minus log a squared in the base 2. So a times b to the half, of course, can be written like this. Minus log a squared in the base 2. Another way of writing b to the half, if you remember, of course, is root b. Yeah, from your laws of indices, b to the power of a half is the same as square root of b. Minus log a squared in the base 2. And now, of course, I'm subtracting logs using my second law. What I can do with that is I can take a root b divide by a squared in the base 2. I can divide this, divide by this, when you have the subtraction of 2 logs. And I can simplify this further. Of course, a goes into a squared a times, so I can do a little bit of cancelling out there and end up with root b over a as my final answer.